So today I'm going to speak about adopting DevOps practices to achieve security and compliance. A few words about myself. Thanks for that introduction, Rado. Yes, even though that I'm at the manager position, I'm still a very hands-on person. I have 8 active AWS certifications, and I do hands-on work myself as well. I'm also a trainer for AWS training, and I do DevOps training for Telerik Academy as well. Something that I'm very proud of is the AWS Community Hero part, because this is a group of people which is below 250 around the globe. So definitely very proud to be one of that awesome group. Moving on. Now, when it comes to regulated industries, and I've listed just a few here, we see multiple challenges in that fast pace of iteration. Now, DevOps brings a lot of automation in the software development lifecycle, and we are used to these fast feedback loops, fast delivery streams. But when it comes to regulated industries, and when it comes to security and compliance, we might see some blockers along the way. And let me guide you through that part, how we manage to move these blockers and still keep the fast pace of software delivery. I'm going to review 2 big topics today. One would be the infrastructure, and the second would be the application front. And now, when it comes to infrastructure, how do we address the need to produce secure and compliant infrastructure? Now, in the old days, when we needed to create infrastructure, let's say virtual machines or some object storage or a relational database or maybe some analytic services, we needed to go and then click here and there to start a virtual server. So it used to be a very manual process. Nowadays, if we think about how we operate with both public and private cloud vendors, is that they provide an API so that we can, in an automated fashion, create infrastructure. And this approach is known also as infrastructure as code, so that we treat the infrastructure in the very same way as we treat our application code. We keep it into a version repository, we do peer reviews, and that all happens even before we start creating that infrastructure. Let me review some of the benefits of the infrastructure as code. Now, obviously, if we keep our infrastructure in our version control, let's say Git repository, well, it's auditable, right? We can trace who, when, and what was changed. We have a full audit walk of what has been changed. Another key aspect of the infrastructure as code is when we execute this creation process, well, it's a consistent one. We have already defined all of our resources as code. So think about the difference. If we need to create, let's say, tens of environments through infrastructure as code, it will be much consistent than having a person going through a checklist and creating them all manually. Obviously, as we keep our infrastructure as code, it's well documented as well, because it's there in the Git repository. Now, why we say that it's even more secure than the usual approach? Well, we can do peer reviews even before we start creating this infrastructure in production, so that we can apply even automated security checks as part of our delivery pipeline. And here I've depicted just a standard delivery pipeline where we have the code and we want to deploy it. Now, if it's a if that process is automated, right, as a pipeline, we can review, we can do the peer review, we can apply automated security checks, and then we can approve that and deploy to production. Now, think about some of the tools that can help us achieve all that are just Terraform is probably one of the most widely used tools to achieve that. And tools like Chekhov or TFSec can help us and can be implemented as part of our delivery pipeline so that we can have automated checks. And again, think about how awesome that is. We get to know that we are about to deploy a non-secure environment, right? So we catch that even before it goes to production, and that is awesome. Now, I would like to share how the public cloud can also help us achieve our high security and compliance standards. First, the data topic. Obviously, it's gaining more and more traction. We see more people streaming, gathering, and then analyzing data. This is a screenshot of the AWS region map. And all of these are regions. So that means stacks of data centers across the globe. So that when we want to deploy our application, either based on latency, to be the closest as possible to our users, we can also choose where to reside based on our compliance regulations. Right, so that if we want to be GDPR, we can keep the data in Europe and then build a, let's say, primary region in Ireland and then build a disaster recovery region in Frankfurt, right? If we want to comply with California Protection Act, well, we can deploy in US. So that's one way that the public cloud vendors can help us achieve our data regulations. Another way that the public cloud vendors can also help us achieve secure environments is by them providing the so-called reference architectures. Now, this is just an example of the AWS HIPAA guide on how to deploy HIPAA and high trust, which addresses the healthcare domain. And we can use that as a guiding light. Even if we don't use or reuse it as is, we can just use this as a guiding light. We can see that also the public cloud vendors provide infrastructure as code. So we can take that very same code, modify it based on our own needs, and then achieve the framework that we are targeting. Probably one of the hardest things to achieve when it comes to compliance frameworks, and I don't want to dive into the details here, I just want to use that as an example, is probably that at the left-hand side, we see all that security controls, and I have chosen the HIPAA control checklist here. When we think about how the public cloud vendors can help us is by them providing a mapping between the security controls of a framework and then the actual tool chain or set of services that can help us achieve all that. And that saves a tremendous hours of time. And if you have that need, please consider reviewing that security control matrices based on the compliance framework that you have to achieve. Now, another way that the public cloud can help us is through managed services. And I have taken an example here about a relational database. Think about it. If we have to manage a relational database in our on-premises data center, well, we are responsible for all of the for every layer in that stack. So we need to rack and stack the servers. We need to maintain the hardware there. We need to install the operating system, then patch it, then install the database, then patch it, then create backups and scalability and high availability, which is not usually a very trivial thing to be done. Now, if we consider the picture of at the right-hand side, we can see that just a few layers are handled by the public cloud vendor. Now, think about it. We are using, let's say, in this case, AWS, and we start a virtual machine, and then on top of it, we start deploying our database. Now, if we just look at the layers, at least a few of them are now responsibility of the public cloud vendor. So when we have audit, what will happen? Well, the auditor will only audit us at the top right layers. Everything else would be responsibility to the public cloud vendor. And now think about it. If we are using a managed service, a fully managed service by the public cloud vendor, now every layer except the application optimization is managed by them. So when you have an audit to be performed on your infrastructure, well, it's them, it's the public cloud vendor that will be audited. So that saves tremendous hours of time. So when we consider would one service be cheaper or more expensive than another, consider that these services that the public cloud vendors provide, they have already passed multiple compliance and regulation audits. And I've provided here just a few of the compliance regulations that AWS is part of. The majority of services in AWS have already passed the ISO standards and PCI DSS if you work with credit cards, and the SOC levels as well. But if you work with the government, maybe FedRAMP is what you want to address. And then also in the healthcare domain, we see HIPAA and HITRUST. And these are just a few. We can also see multiple regulations and compliance programs in the fintech industry, and a lot more. Here I've provided just an example of the clients that the public cloud vendors have, and in this case, AWS. So if NASDAQ is using it, and then Robinhood is all in AWS, and we see banks fully using all in the public cloud, and governments using the public cloud, we see companies in every business vertical adopting the public cloud. And sometimes I hear, well, public cloud might not be as secure as I want it to be. And please consider reviewing this testimonials page if you still consider that. If it's secure enough for NASA, and if it's secure enough for CIA and the Department of Defense, it's probably secure for your business as well. Now, the second topic that I would like to address is the application code and our source code. Here, I'd like to quote Gartner, and they say that security and risk management leaders can meet tighter deadlines and test more complex applications by seamlessly integrating and automated application security testing in the software delivery lifecycle. They've produced a report earlier this year. I've left a link to the resource page so that I will leave for you to see the details there. But what are the application security testing tools and the tool chain around that? I would like to quickly review these. Again, I've depicted at the bottom just a standard pipeline where we have build, test, and deploy phases. But then if we want to start automating the security part, how do we do that? Well, first, we can implement the static application security testing, or so-called SAST. It looks very much as the standard static code analysis. It reviews, the tool chain reviews our source code, right? And then provides us feedback. And some of the software vendors of these tools provide even integrations with our IDE. That means that we can get that fast feedback loop really, really fast. We can see that there is a vulnerability in our code as we write it. So that is one option here. A few tools that I've mentioned here, and of course, please consider reviewing the Gartner provided ones here too that are not represented there, but are valuable tools. Now, the second approach would be the so-called dynamic application security testing. And to an extent, that very much looks like a penetration test. So we do a scan of our code security after it has been deployed. And we can deploy it to an internal environment, scan it there, and then move it forward in the pipeline. A few tools that exist in this context is the OWASP ZAP project, then Burp, and of course the Kali Linux comes with also a lot of handy tools to achieve that. Then interactive application security testing, that type of tools operate inside our application and can detect vulnerabilities as we test it. Also something that we can implement as part of our delivery pipelines. Now, if we think about probably the last stage, we have deployed our software in production. It now serves production traffic, and we see happy clients. Is there a way for us to implement security even at this layer? Well, there is. It's known as RASP, or Real-Time Application Security Protection, and it generally works as a wrapper of our application. So every query that has been sent to our application first gets scanned, and then if our software says that it's safe, only then it's being sent to the application that we write. Now, when it comes to software dependencies, our software is as secure as our dependencies are, and this is known as a software supply chain management. Our software represents a set of obviously the source code that we write, so there's a first-party code, but then also the libraries that we depend on. Let's say the database connector or our work management solution. So we almost always use third-party code, so that in order for us to know that our whole solution is secure, maybe we need to scan that dependencies as well. And here I would also include the operating system, maybe in the form of a container, but it's also a layer in our supply chain management. How do we address that? There is a set of tool chains which are known as SCA software composition analysis, which helps us track and analyze third-party components or open source projects. And we can, these type of tools usually can even scan an open source project if we are using a project and we do not comply with the license of the open source project. So that's also important for us to know. Just a few examples. Here is the OWASP dependency checker, and we have Sneak, which gains a lot of traction nowadays, and a very simple tool, even like an NPM audit, also can be used. Now, the general approach is how to start. Well, just start small. Okay, start with one simple check, then add until you have that whole holistic picture of security. And all of these tools can be integrated with our delivery pipeline. So we have that fast feedback loops. We know that our software and the dependencies are secure. Now, it won't be a DevOps talk if we don't address the DevOps, cultural aspect here. Yes, when it comes to implementing security, and we need to achieve that high compliance bar, well, the usual advice is, hey, let's sit together. Let's sit on the same table with everybody who has something to add. Break that wall of confusion, the so-called wall of confusion, and just work together. Because in the end, we all want the same thing. We all want functional code, which is also secure. That's a favorite picture of mine. I'd like to depict that, yes, let's just work together even more and not be the people at the top right corner just saying, well, that's not really my problem. The three resources that I'd like to recommend is the Unicorn Project, Accelerate book, and Ahead in the Cloud as well. I've left additional resources here so that if you're interested, please consider reviewing them. And then if you'd like to continue the talk, please do find me. And I'm very open to community and society as well. Yes, so you are welcome to also our gatherings of the AWS user group. You can find us on the meetup.com. And the next time we will speak about FinOps on AWS. So you're all invited to join. Thank you. And now I'm open for questions.
Thanks, Daniel. Really impressive. And I have this question. What was the most challenging part of this journey, actually? From your point of experience?
Right. Well, definitely working in a service company, we implement these solutions for multiple clients around the globe. And I would say that maybe when a person does that for a first time, that's really challenging because you're kind of lost. You don't know where to start. But then once you do, every project from now on, it's just easier. It's more structure. It's just well, you follow the same pattern, and that's just a general advice for a service company. Build that intellectual property inside that company. Knowledge, share these. As the public cloud vendors share with us these reference architectures, well, we can also share them and build our own internally. So that's a way for a company to scale in that manner.
Yeah, we have a question from the audience. In which stage we have to implement security validations from non-functional testing, like penetration testing, and how we can do this in order to achieve end-to-end automation?
Right. Well, as every consultant in the world will tell you, it depends. Right. It depends on your business needs. I've worked for projects and we've implemented projects that we had that security guardrails right from the beginning. So we did not even have functional code, but we had all of the security tool chain implemented so that we know that no matter what the features are, we know that the software is secure and it complies with the regulations. And it's easier. If we try to retrospectively implement security, it usually creates a lot of hustle. I'd have to tell you, probably you would need to break the whole infrastructure and then recreate it. And just a very simple example is if you create your whole infrastructure and you're happy with how it functions and everything was tested, and then you find that you don't do encryption at rest, so that your volumes, your storage, your object storage, your databases are not encrypted. Well, in some cases, you need to recreate all of that. So you first need to destroy it and then recreate it. So that kind of implements a lot of hustle. So again, it depends. I would say that it is a business decision on when to do it. The earlier, I guess, the better.
Yeah, definitely. But from another point of view, talking about DevOps and culture, how this is accepted by the team? How do you explain to the engineers that they have to take care for this from the very first stage of the development process?
Right. Well, it's the DevOps mantra. It would be just culture. We should over communicate all of these. Again, otherwise we might end up with frustrated teams and teams that say, "Well, we've built our software. It's running. It's well running. Why it's not passing these checks?" So the earlier we implement it and the more automation we create, just the better. But then again, in every DevOps conference. For all the big companies, they say they have these 5-year plans of how to implement DevOps culture within the company. Their general advice is over-communicate. Just speak more about the issue and address it. And of course, provide well documentation, single source of truth.
Yeah, I'm asking also because there are some cases when at some stage the OSS check pass, but at some stage we found a new vulnerability, and for some reason, and for this reason, the pipeline fails. So this is something that I haven't introduced, but for some reason I have to work once again on my project to fix this issue.
Absolutely. Fast feedback loops. Again, we are all in the same boat. It wouldn't matter if it's my fault or my colleague's fault. We are in the same boat. That's kind of my approach, at least.
Okay. Thanks, Daniel.
Thank you very much.
It was great.
My pleasure. My pleasure.
Thank you.
Thank you very much.